All right, this is Algebra 1, lesson 8.2, zero and negative exponents. We're evaluating powers that have zero and negative exponents. Then we're going to, if we have time, get to graph and exponential functions. They actually are much easier looking, or easier than they look. Beginning on page 456 in the textbook. First thing is a definition of an exponential function. An exponential function is a function, the form y equals a times b to the x power, where x is a real number. B is, notice it says greater than 0. That's just code. That means positive. And b is not 1. So that's your exponential function. It's b raised to an exponent that's not 1 and it's positive. Let a be a non-zero number. Let n be a positive integer. A non-zero number to the 0 power is 1. Okay. Now, most people understand what exponents mean. Most people understand that if I do 5 to the 4th power, that means 5 times itself 4 times. Most people understand that if I do 5 to the 3rd power, that means 5 times itself 3 times. If I do 5 to the 2nd power, that means 5 times itself 2 times. And if I do 5 to the 1st power, you never write that. But if I do 5 to the 1st power, that just means 5 times itself 1 time. Most people understand that. When 0 comes in as an exponent, the answer is going to be 1. And I'm going to show you why. This is the best explanation I've ever seen for this. All of this stuff up here, people don't really remember or understand very well. 5 to the 4th power is not just 5 times itself 1, 2, 3, 4 times. It's 5 times itself 4 times, then it's times 1. 5 to the 3rd power is not 5 times itself 3 times, or it's not just that. It's 5 times itself 1, 2, 3 times 1. Squared is 5 times itself 2 times 1. To the 1st power is it times itself 1 time times 1. So it just acts like a tree going all the way down. That's the reason why 5 to the 0 power, or anything to the 0 power, is 1. So anything being raised to a 0 power is going to be 1. A to the negative n, anytime something is written with a negative exponent, we do what's called the elevator rule. Again, that is not one of those math terms. We understand what elevators do. They go up and down. Somebody said, well, what about if they go sideways? This is not Hogwarts. This is not Gringotts or whatever it is. They don't go sideways. They go up and down. So the elevator rule means is if at the top of a fraction, if 2 is being raised to a negative exponent, it doesn't even matter what the exponent is. If it's negative, 2 goes down to the bottom of the fraction, and it becomes 2 to a positive value of whatever the same thing is. Okay? If it's at the bottom of a fraction, it rides the elevator up to the top. That's all you do if something is raised to a negative exponent. Example number 1 is powers with 0 and negative exponents. So 4 to the negative 2. You have to understand first that everything is over 1. It's raised to a negative exponent. Ride the elevator down. Now, when it rides the elevator down, you're not left with 0 over 4 squared. Because if we're left with 0 over something, then that means 0 divided by something. So the whole thing will come out to be 0. So it can't be this. That's why 1 is left on top. So 1, 4 to the negative 2 goes down, and it becomes positive 2. And you square 4, and you get 1 over 16. So 4 to the negative 2 is the reciprocal of 4 squared. Anything raised to a 0 power, anything, is 1. 7 to the negative y power. Again, it doesn't matter what this is. If it's negative, it rides the elevator. It goes down, and it becomes 1 over 7 to the positive y. So it's the reciprocal of 7 to the y power. And then 1 over 9 to the negative 1. It's the reciprocal of 1 over 9. Or you can make sure to give the negative 1 power to that. So that'll be 1 to the negative 1. And you can make sure to give it, it's like the distributive property again almost. You can give it to that one. Both of those are being raised to a -1. So 9 goes up and 1 goes down. So it becomes 9 to the first power, 1 to the first power, which becomes 9. And then E, 0 to a negative value, has no reciprocal. This is the only version like this, because 0 is 0 over 1. If it's being raised to a negative value like 2, when it rides the elevator, now 0 is going to be on the bottom, and that's something that cannot happen. That's why there's no reciprocal. That's why 0 to a negative value is undefined. Okay, on the back, here's some problems you can do really quick. 3 to the -4th power. Take 20 seconds. Okay, we got 3 to the -4th. Remember, everything is over 1. It's being raised to a negative value. Ride the elevator. When it comes down, it becomes 1 over 3 to the 4th power. 3 to the 4th power. 3 times 3, 9. Times 3, 27. Times 3, 81. Times 3 is 1 over 243. If you can get to this step, I'm happy in 10 seconds. Got to ride the elevator. Look at this one. 10 seconds ago. Okay, let me make a correction real quick to this one. It's not 81. I went too far, apparently. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Again, like I said a second ago, though, if you can get to this step in 15 seconds, that's what I wanted you to do, though. We can do B right now, -5.2 to the 0 power. Anything to the 0 power is what? 1. That's what you got to know, everybody. You got to know that. Anything to the 0 power is 1. Here we go, do this one. Being raised to a negative exponent, everything's over 1. Negative means it rides the elevator down. 1 is left on top, 4 comes down, and is raised to the positive y. 1 over 4 to the positive y. Do this one. All the negative exponent means is to ride the elevator. 3/5. It's the reciprocal of this. You could say, well, it's negative, so I'm going to use a reciprocal, 5/3. Remember, reciprocals is a fancy word that means flip it. If that doesn't work for you, you can give the -1 to that one, and you can give the -1 to that one. Both of those are being raised to a negative. This rides the elevator down. This rides the elevator up, and you get 5 over 3. Do this one. Okay, we got 0 being raised to a negative exponent. Everything's over 1. Since it's a negative exponent, it rides the elevator down. 1 becomes over 0. This cannot happen in math. 0 can't be at the bottom. This is an undefined answer. Example number 2 is simplifying exponential expressions. 7 times 4 to the -y. 4 is being raised to a negative exponent. It rides the elevator down. So notice 7 is multiplying times now 1 over 4 to the positive y exponent. So it becomes 7 times that. Everything's over 1 when you multiply straight across with fractions. 7 over 4 to the y power. 3 x to the -4th, y to the -5th for B. This is being raised to the -4th, not 3. So 3 stays on top. X to the negative fourth goes down and becomes to the positive fourth. This is being raised to the negative fifth. It goes down. 3 stays on top. X to the fourth goes down. Y to the fifth goes down. 3 over X to the fourth, Y to the fifth. C, D to the negative 2. Just like from Monday, this gets given to both things. So 6 gets raised to the negative 2 and D gets raised to the negative 2. Both of them ride the elevator. 1 stays on top. 6 goes down and becomes 6 squared, which is 36. D goes down and becomes D squared. 1 over 36D squared. 1 over C to the negative 2x power. C is being raised to a negative exponent. It rides the elevator up and becomes C to the positive 2x power. That's all you can do with this stuff. 0 exponents means 1. Negative exponents means elevator. Do this one on the back. 4 times 3 to the negative k power. Remember what a negative exponent means. Take 15 seconds. Okay, the only thing being raised to a negative exponent is 3. Everything's over 1. This is the only thing that's going down. So 4 stays on top, 3 goes down and becomes raised to a positive exponent. 4 over 3 to the k power. Do this one. Again, 5 is multiplying by G is multiplying by H. But G and H are being raised to negative exponents, not 5. Everything's over 1 since there's no fraction. This has to ride the elevator down. This has to ride the elevator down. 5 is going to stay on top. G is going to go down and become positive exponent. H is going to go down and become a positive exponent. 5 over G to the third, H to the fourth. Example number 3 is evaluating exponential expressions. 2 to the fourth times 2 to the negative fourth. Same base, add the exponents. Use the product of powers property. 4 plus a negative 4 means 4 minus 4. 4 minus 4 we know is going to give us the number 0. So we're going to have something that says 2 to the 0 power. Anything to the 0 power is 1. 3 to the negative 2 to the negative 2. Now you're raising a power to a power. That means you multiply the exponents. We know a negative times a negative is a positive. That's going to give us 3 to the fourth power. That is the power of a power property. 3 to the positive fourth power. And 3 to the fourth power, we're not going to go as far as we went a minute ago, is 81. 2 to the negative 6 power means 2 rides the elevator. Everything is over 1. It becomes 1 over 2 to the positive 6 power. Remember, it's the reciprocal of that. 2 to the positive 6 power is 1 over 64. And then for some reason they include the decimal estimation there. 1 over 64 is where you would stop without the blank telling you to use a calculator. On the back, evaluate this expression. 4 to the negative third times 4 to the positive third. Take 15 seconds. Okay, we got 4 to the negative third times 4 to the positive third. Same basis, 4 and 4. You add the exponents. 4 to the negative third plus 3. Negative 3 plus 3 is 4 to the 0 power. Anything to the 0 power is 1. Oh, forgot I had C. Do this one. Leave it as an exponent, everybody, where we can go fast with it. Okay, this comes from what we did Monday, 5 to the negative 2 to the negative third. A negative times a negative. We're going to multiply these. Is going to be a positive 5 to the positive 6. Again, you can go further than that with it, but just so we can go faster, we won't. What about 2 to the negative third? Do that one. Okay, remember a negative exponent means ride the elevator. 2 is being raised to that. It goes down. 1 stays at the top. 0 can't stay at the top because then the whole thing would be 0. It becomes 1 over 2 to the positive third. Since it comes down, it goes from negative to positive. 2 times 2 times 2, we know is 1 over 8. We're going to skip the checkpoint real quick and come back to it. Let's go look at example number 4 below the checkpoint. It says graphing an exponential function. Graph the function y equals 3 to the x power. Then notice these values for x. These values come from the easiest numbers there are to multiply almost all the time. Negative 2, that means 3 to the negative 2 power. That's where you're plugging in for x. That's a negative exponent. 1 stays at the top, 3 goes down, and it becomes 3 to the second power, which is 1 over 9. Same thing with the next one. 3 to the negative 1 power. Again, it rides the elevator, it goes down, 1 over 3. 3 to the 0 power. Anything to the 0 power is 1. 3 to the first power is just 3. And 3 to the second power is 9. That's where those numbers come from. Then you graph all of those as ordered pairs. You graph the first ordered pair looks like this. It's this relation, negative 2, 1/9. So your x value is negative 2. Your y value is 1/9. So at negative 2, 1/9. The second one is this one. Negative 1, 1/3. So at negative 1, 1/3. At 0 is the next one, is 1. There. The next one is 1, 3 at 1, 3. And then the last one is at 2, 9. At 2, 9. So notice it's an exponential function. When you graph it, it curves. It is not a straight line like you're used to graphing. But it is very simple by simply plugging it in. Notice that the graph has a y-intercept of 1, and it gets closer to the negative side of the x-axis as the x values get smaller. This right here, and this is something we'll just touch very briefly on in Algebra 1, this graph will never touch the x-axis. No matter what number you plug in, it'll never cross to the bottom of that axis. It'll never get to that negative value down there. It'll keep getting closer and closer and closer and closer, but it'll never ever get there.